Folks, let me talk about the last model here, which is a linear regression, okay, which is a causal model. So remember, I told you before that whenever you have the data, the first thing you need to do is plot the data that you have against the time and see if there is a pattern. If there is a pattern that explains, yes, over the years the sales have been increasing, or you see a cyclical or a seasonal movement, etc., then go with the time series forecasting methods. Okay, now when you plot and when you cannot discern any pattern, any data there, then time cannot explain the behavior of the dependent variable, which is, for example, let's say sales or revenue. Then in that case, go and then look for an independent variable that induces this change in the dependent variable sales or revenue. Okay, then if you find a relation there, plot the data and see if you can see a relation. If you see a relation, then yes, it does explain the behavior of the dependent variable. So one causes the other. That is why we call this causal model. In this case, we look at a simple model, which is linear regression. There could be multiple variables. Now here in this case, we look at only one variable. There could be multiple independent variables, and the relationship can be linear, or the relationship can also be non-linear. It can be either also. Okay, now let's go with a simple model here. Now in problem 1036, a firm advertises spends so much money on advertising dollars, and accordingly their sales either go up or go down based on the dollars that are committed for the advertising. Okay, now if you take that and then if you plot, this is not exact plot of that one. I just have some some representation here to explain the concept behind it. Now over here, as you can see, there is a gradual increase, and this line that goes through these data points, actually what it does is linear regression. What it does is it finds the line in such a way that the distance between the line and the data point, that is the error, the sum of those square errors are minimized. That's how it fits the line, and that's a linear regression. Okay, and that line is given by y, that is a dependent variable. In this case, dependent variable is sales, independent variable is advertising dollars, because this is what is within our control, and we spend the money whatever that we want to. That's our independent variable. Dependent variable is based on our action, what are the resulting sales. Okay, so that's a dependent variable. Dependent, independent variable. Okay, now the dependent variable estimation is the y equals a. A is the point called the intercept, where this line intersects with the y-axis, in this case the sales, plus b. B is the slope of the line. What the slope basically says is, for 1 unit increase in the independent variable, in this case for, let's say, 1 unit increase, let's say $1,000 increase in the advertising dollars, what is the resulting change in the, for 1 unit increase, what is the resulting change, that's increase in the sales. Okay, so that is the slope of the line. That's what it measures. Okay, now here I have put in the data already. A, that's the intercept, is given by the formula intercept. Once you do that, known y and known x. So look at the argument. The argument is known y's. Y is always a dependent variable, so that is the known y's, comma. The second argument is known x, which is the independent variable, that is our x. Similarly, the slope equals, again the same, known y's, that's a dependent variable, and the independent variable, that's that one. Okay, now the regression equation for this is y equals a plus bx. A is 8714 plus bx, b is 0.031 times x. X here is nothing but the independent variable, that is the advertising dollars. Okay, Now part D of the problem is, of course, the first part is which is the independent, which is a dependent variable, plot the data on the graph and all. Now you know how to graph that. Okay, this is independent and that's a dependent variable. Go and then choose from the chart the XY scatter plot and do it like the way that we have done before. Okay, but I'm going to show you another way in which Excel does everything for you. Okay, let's go through this method first. Now part D of the problem is forecast the sales that would be attained by expending $30,000 on the advertising. $300,000 in advertising. $300,000 in advertising falls within the range. So here the range, the equation is valid only for this range and not beyond. Okay. So 225 is the smallest value that I see and 450 is the largest value. So 300,000 is in between, so hence we can use that. For $300,000, for 300,000 advertising dollars, okay, what is the resulting, y equals A, that is 8714, plus B, which is 0.031 times X, in this case 300,000. So y equals let's do that, 8714 plus 0.031 times 300,000 equals, I don't know, say 18,014. So based on the data that we have, if you were to spend $300,000 in advertising, our forecast is that we will get around 18,014 in sales. In this case, these are the number of passengers on the cruise lines. Okay, so that is that part D of the problem. This is part D of the problem. Part E of the problem is estimate the amount of advertising that would need to be done to attain a booking of 22,000 passengers. Okay, so here let me set up the model. Let's just go ahead and then do the goal seek function that we used to do before, or you can just use the algebraic manipulation, in which case we know the y as 22,000 passengers. We know 8714 plus 0.031 times x. X is what is unknown. Then just do the algebraic manipulation and then you get it. Or the easiest way is to go do the goal seek. In the goal seek function, the number of passengers, which is y equals A, that is that one, plus B, that is that, times X. X is the advertising dollars, which is this case. Okay, we get that one. Now go to the goal seek function. Data, goal seek. Okay, set this number of passengers to, the problem says 22,000. 22,000. Changing cell is the advertising dollars. Point the advertising dollars, click OK. It finds you. That just expand that cell. So you have to spend $422,727 to get 22,000 passengers on this cruise line. So that's part E of the problem. Part F of the problem is according to the regression line about how much increase in sales can be attained on the average per $1,000 increase in the amount of advertising. So in other words, so if you were to increase 1 unit here, that is in this case $1, we are going to increase it by 0.031 passengers. Okay, now here we are asked for $1,000 increase. For $1,000 increase, how many passengers would we increase by? That is, multiply this 0.031, which is the slope, 0.031 by 1000, so we increase by 31 passengers. Okay, that is, answer is by 31 passengers. Okay, we got this by nothing but take this slope 0.031 times 1000. That's how we got this. Okay, by 31 passengers. Now, what I would like to do is I would like to show you how to do the same problem using the Excel. Okay, I mean, of course we use the Excel, but we use the other formulas, but there is another thing that we can use. That's what I want to demonstrate next. Let me do one thing. Let me copy that information onto another sheet. Okay, copy, paste. Okay, here we have that one. So what I want to do is I want to show you how to use the what I want to do is I want to show you how to use the data analysis. So go click on the data and data analysis, click on that one. Okay, and so in this list that you have there, go down to the regression, choose the regression, click OK. Then it tells you the input the Y range. Okay, input the Y range. I have inserted all, I have chosen this including the sales. Then input the X range, and X range again, I have chosen including the labels. Okay, from B3 to B8, B3 to B8 including the labels. So that's why I check the box labels. It's already there. Then over here I want that to be put in a new worksheet, or if you want this on the same worksheet, you give the output range over there, or a new workbook. So here are some residual plots, and I was trying to see, like is there any plot. I was able to do that with the earlier version of the Excel, but here I could not. Is what it does is it gives you the output along with a graphical representation of the points and the line that fits through that, very similar to the one that I had on my sheet to begin with when I started the lecture on this topic. Okay, click OK. This is the sheet it adds. So let me increase the size to font size 14 so you can see that better. Okay, and summary output, if you see here, this is where you get the intercept is 8714. That's what we got. Here actually it does give you for the decimal places, where in the earlier one we did not have. And the slope, advertising dollars, that's the slope is 0.3014. So this is the slope. Slope is that, and the intercept is right there. So let me just go, let me highlight those and as hello. So y equals, this is another way that you can get is 8714.29 plus 0.0314 times x. Okay, so that's what we got in the earlier one too. Okay, so this concludes the discussion on the causal model. Okay.